Hey Spartans! You're used to seeing traditional Venn diagrams like this one here, comparing dogs and cats and in the center of what they have in common, like fur and four legs, on most of them anyways. They're both mammals and they like to play, except for my one cat Bill. She's interesting. And they both have tails, unless it's a dog that doesn't have a tail anymore, or a bobcat. But they do have a little nub. Now what we're going to discuss are a new Venn diagram that's called a nested Venn diagram. So let's take, for example, mammals. There are lots of mammals. You've got monkeys and horses, and of course dogs and cats and elephants and dolphins even. But let's talk more specifically about dogs. Do you agree that all dogs are mammals?
Yes, Miss Hester.
So that means it's inside the mammal circle, but are all mammals dogs?
No, Miss Hester.
Let's go more specific of dogs. Labrador retrievers. Are all Labrador retrievers dogs? Yes. And all dogs are mammals? Yes. So it's safe to say that all Labrador retrievers are also mammals. If it's inside the circle, that means it's included. Now, are all dogs Labrador retrievers? No. You can have another circle out here saying Chihuahua. Okay, so we're going to use a nested Venn diagram to describe natural numbers, whole numbers, integers, and rational numbers. Oops, sorry. Okay, here's our notes. Turn it this way. Focus and zoom. What I'm going to do first is take a purple marker and highlight this inner circle here. Now the brain learns in color, and we're going to compartmentalize with these colors. I'm going to take a blue highlighter or marker and circle the next circle on the outer part here. Alright, and then I'm going to go green, and circle this one. And then finally I'm going to get orange. I think it's orange. Let's find out. Enjoying my new highlighters here. Kind of a pinkish orange here. But I'm going to take 4 different colors and compartmentalize each one a different color. Okay, let's start on the inside. These were the natural numbers. Natural numbers are simply counting numbers. So if I were to say count to 5, you would start with 1, 2, 3, 4, 5. So a natural number is any number that you start with by counting. You could count to 212. You can count to 78. You can count to lots of different numbers. So if it is a counting number, it's a natural number. Okay, now I'm going to switch to blue, and we're going to talk about whole numbers. Now, all of these natural numbers are inside the whole numbers. That means they're whole numbers too. Kind of like the Labrador Retriever was also a dog. But what isn't a natural number but is also a whole number is the number 0. So whole numbers are 0 and then all the natural numbers, 1, 2, 3, 4, 5, infinity. Okay, let's go green. Green are the integers. And as we've been discussing in class, integers are positive and negative numbers, but no fractions or decimals. So what integers include are all the whole numbers, which are the natural numbers and 0, and it includes their opposites, like negative 21, negative 3, negative 1, negative 7. So integers are all the whole numbers and their opposites on the negative side. Okay, finally, the rational numbers. This is what we're missing. There we go. Okay, rational numbers include all of the integers, which are positive and negatives and 0, but they also include fractions and decimals, like 1 1/2, negative 0.5. So if I cannot make it into a natural or a whole number or an integer, and it's got extra fractions and decimals on the side, 3 2/5, that means it's a rational number. And rational numbers can be positive or negative or 0 or have fractions, even improper fractions like 7/5. And negative, I don't know, 21, my favorite number, over 10. Because 21 divided by 10 would be a negative 2 and 1/10. See how it keeps the fraction? Or it could even have a decimal, like 0.125. Which one is that? That's a 1/8, 0.125. So rational numbers include all the numbers we're talking about, fractions, decimals, whole numbers, integers, natural numbers, all of them. And if it's inside this big circle, that means everything in here is a rational number. If it's inside the integers, that means everything inside is an integer. If it's inside the whole numbers, 0 and the natural numbers, then they're all whole numbers. And then the natural numbers are the counting numbers, starting at 1 to infinity. Okay, so let's go down below. Now we have a negative absolute value of negative 8. So, but on the slideshow, I believe it was just a 5. So I'm just going to go ahead and take that off and put 5. Now, can 5 be written as a fraction in a over b form, meaning it has a numerator and a denominator? It sure can, because if I put 5 over 1, what's 5 divided by 1? It's 5. Now, if I can put it in a-b form, that means it is definitely a rational number. But isn't 5 right here in the natural numbers, which means it's inside the integers, it's inside the whole numbers, and it's inside the rational numbers. So 5 is everything. Okay, 1 1/2. Let's make it have just a numerator and a denominator. The way I do that is the Texas 2-step. So I take 2 times 1, which is 2, plus 1, which is 3. And then I keep the denominator 2. So 1 1/2 is equivalent to 3/2. Is that a rational number? Yes, it's an a over b form. Is 1 1/2 considered an integer? No, it is not. So 1 1/2 is just a rational number. Okay, the negative 0.5. That would be negative 1/2, looking at the a over b form. And that would be considered a rational number, but it does not go in any of the other columns. Okay, negative 3. Just like the 5 over 1, I could put the negative 3 over 1, making it a rational number. But wouldn't negative 3 also be inside the integers? Yes, it would. All right, so let me put a check there. Oops. But it is not a whole number. It is not a natural number. Okay, 0 would be 0 over 1. Can you have 0 on the top part of a fraction? Yes, that would be okay. Can you have 0 on the bottom part of a fraction? That would be an NO. Ha ha ha. So 0 is also a rational number. But if you look up here, it's considered a whole number, making it also inside the integers and inside the whole numbers. So 0, rational, integer, and whole. It is not a natural number. Okay, this has a 17.0, but the 0.0 can drop off, making it just 17, and we can make it a fraction over 1, making that a rational number. 17 is also an integer. It's also a whole number, and it's a natural number, because if it's inside the natural numbers, it's inside all of the circles. Okay, and finally, okay, 7/5. Yes, it's rational because it's already in a over b form. But if I were to make this a mixed number, 5 goes into 7 one time. I got 2/5 left over, making it only a rational number. It would not be an integer, whole number, or natural. Okay, these will go in your notes. Have a great day.